and welcome back to my channel where we do all kinds of projects and challenges that are Python related. Today we're talking about Free Code Camp's probability calculator that is at the end of their scientific computing with Python course. I'm going to put a link down below so that you can click on it and hopefully come along with us for the ride and we can code together and have a little bit of fun. So what's this project about? Well, first you need a hat. I got mine. Go ahead and grab yours and throw it on. I got my trusty cowboy hat on here, which kind of took a beating in the move, but that's okay. We have a hat and we also need a whole bunch of balls, which I don't have because A, I'm a girl, and B, my kids are all grown up and they don't play with toys anymore. So we're gonna have to make these balls digital and we're going to put them in a hat and we're gonna shake them around, and that's when the magic starts. Now imagine with me for a moment, we have this hat, we have all of our balls inside, and we have a wish. Our wish is that in this hat with all these different colored balls, we want to pull out a specific color ball. Okay, let's say that we want to pull out one red ball and two green balls. We do that once. Do we get the color sequence that we want? Probably not. So if we don't, we just mark it as experiment number 1 did not happen. Let's try it again, but we can't put the balls back in the hat. So let's pull out 3 more balls. And what are the chances that our sequence or color scheme that we're looking for is going to come out? Obviously, if there's no balls replaced, our chances are going to go higher that we get the color sequence that we want. So on that second experiment, we may get the sequence that we're looking for. So if we do, we write that down on the second experiment that yes, we got the sequence that we wanted, until there are no more balls in the hat, and then we put them all back in and try again. What this project is asking for is that we do this 2,000 times, and then we take that percentage of how many times we were successful and return it in a program. So hopefully that all makes sense. Let's get to it and write the program. Well, I hope you didn't think that I was going to actually do this whole tutorial in my hat, but I had to take it off, okay? I'm actually going to want to put my hair up so we can get busy and get it done, and I don't have to worry about my hair being in my face. So let's just throw it up here and I'll be able to think a whole lot better. Okay, get my clip in here. Okay, better. The first thing we want to do is create our hat, and we can do this a little backwards by first creating our hat object like this. I have a pass in the conductor right here, so let's create our object, hat 1, and this is the contents of our hat. So we're going to have 6 black balls, 4 red balls, and 3 green balls, like so. For our first hat, we're calling it hat 1, and this is the contents of our hat. We know from the instructions that our hat class, we need to create the contents of our hat as a list of strings. We can create our contents of our balls as a dictionary by using the double asterisks in the argument within our conductor right here. So what this does is it takes the keyword from our hat 1 object, which is the color, and then it multiplies it by the integer or the number and puts that in a list. So I can show you how that looks like this. We know that it's a list, and we know with the double asterisks that our balls in the hat are a dictionary. So for key and value in balls.items, all we need to do is add this to the list, which will be multiplying the color by the number or the integer. So it's self.contents, we're adding to it key times B. And I'll show you, let's print this out. Print hat one dot contents. Let's run it. And there it is. 6 black, 3 or 4 red, and 3 green, just like that. Okay, great. We have our hat and we have the balls inside the hat. So what we need to do next is create the draw method, which is going to take one argument, the number. This is going to be the number of balls that we're going to pull from the hat. So let's look to the screen now, and we need to draw these balls out of the hat, and they need to be completely random. We don't know which colors we're going to draw out, right? So we need to import random, and we're going to start writing our method. So we're going to define draw self with one argument, which is num. And I'm gonna put a pass in here real quick because we're gonna do the same thing that we did in the conductor, which is hopefully going to show you a little bit more of when this way, doing it a little bit backwards. I know that seems weird, but we can print it out as we go so we can see how the program works. So I'm gonna write hat1 dot draw, and I'm gonna put a 3 in here because we're gonna draw 3 balls out of the hat, right? And per the instructions, we know that there can be at least 1 ball in the hat. So in order to account for that, we need to make sure that the num is, it has to be lower than either the number or the minimum. So we're going to do min between num and len of the contents of the hat. So that's our fail-safe right there. And per the instructions, we need to take our draw and put it into a list of strings very similar to the contents of our hat. So I'm going to make it called ball draw. And again, we're going to set it as an empty list. Okay. And what we need to do next is loop through our num. So for x in range num, for each ball that we draw out of there, we're going to make it we'll create a variable r balls for random balls, which is going to be us initiating the random built-in. This is going to be random integer, and that needs to be between 0 and length of the contents -1, because we know that in Python, the indices is 0 to 12. There's 13 balls in the hat, but the way Python works, I'm sure you know at this point, it needs to be from 0 to 12, okay? And so what we're going to do there is we are then going to, I'm going to print this out so that you can see how this goes into here. So what it's doing right here is it's picking 3 random numbers, okay? It picks 11, 3, and 6. And what I should do is print out our contents, so you can see our contents. Okay, just like that. Okay, and now that you see here what our contents are, we're going to append these random numbers, random balls, into our ball draw list. And we're going to append it with our contents, but we're going to pop those balls off. So our balls. Now let's print out our new contents after this. Now you're going to see each time the random numbers are going to change every time you run it. So now it's 8, 11, 1. So it's going to pull at index 8, the 8th index, the 11th index, and it's going to go down, 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 because it's popping off each. It's not putting the ball back into the hat, if that makes sense. So I'm just printing this out so that you can hopefully see how this is working. And let's see, I'm gonna take these out now here. Let me just erase those. Oopsie. Erase those. And now what we need to do is return our ball draw like so. Reprint it. And now we'll print the hat draw. Now we have a list of the 3 balls that were drawn from the hat. And if I run it a few times, you're going to see it's going to change every time, obviously, because it's pulling 3 new balls out of the hat every time. Okay? And that's it. That's all that we need. This is all we need to do for our class, and we can move on to writing up our experiment function. So let's do it. Hey there. If you made it this far and enjoy what you're seeing, why not subscribe? I upload fresh content all the time. Thanks for watching. In order to do our function for the experiment, I broke this down a little bit so that it could be hopefully easier to understand. And I broke it down into little sections, directions of, and then I will explain as we go what each portion of this does. So to begin, I'm going to make a practice dictionary for the expected balls. So, and for this, we're just going to throw something out there. So we'll make it to be 2 blue balls and 1 red ball, like that. Next, we're going to make 2 lists, which is just for the example so that you can see. It's not how the actual function is going to go. Hopefully this will come together as it goes. We're going to name one ball draw 1, and we're going to make it a black ball, 2 black balls, and 1 red ball. And then for ball draw 2, we're going to make it the actual expected draw. So that will be 2 blue, can't type today, and 1 red. And we're going to need 2 counts, which this is actually part of the function. We need to count for our successes, and we need to count the colors in our draw. So we have, I'm just going to name it successes, or success M equals 0, and we need a color count, which is going to start also at 0. And then we're going to iterate through the colors and the keys. So for color in expected balls dot keys, and we're going to say if the it was, what did I name it? If ball draw 1 dot count color is greater than or equal to our expected balls color, which is going to be the value, which is actually the number, we're going to add it to our color count. And I'm going to, on the directions here, it says then print to see the result. So I'm going to show you what the color count looks like. Color count, so that we can see. So let's run this. Oh, I'm sorry, I didn't put a 0 there. Oh, okay, here we go. Okay, Let's try this again.
Bruh.
Okay, what did I mess up now? We're gonna get this. Okay, so what it's showing is that the color count for each color. So there is, let's see, our expected balls. There are no black ones in here, but there is one red one. Hopefully that makes sense. If we change the ball draw to 2, now let's run it. You're gonna see that it has 1 and then two of our blue. So it matches. Hopefully you can see how that works. Okay, so let's take that out now. And then lastly, we compare our color count to the length of our dictionary. So we do it like this. If color count is equal to len of our dictionary, now we can add a success. So our success equal 1. Now let's print out our success. I changed it back to ball draw 1. This is not a success, so we get a 0. If we change it to ball draw 2 and run it, we have a success. So this is the bulk of the function broken down a little bit by here. So when we take our actual hat and then we take our draw from our hat class and plug that all in with our number of experiments, then we can see the probability. So let's move on over to my next sheet and plug all this in, and that's it. We'll have solved the probability calculator. So let's go. It's time to see what Flaxseed's up to today. Let's check her out. She's not in her water. I'm thinking what I need to do is get a little miniature laptop and set her up on a little chair and have her code with me. What do you think? How many of you would like to see that? Oh, there she is. She's all burrowed in there. I don't think I have a light that I can shine in here. Oh, there's the crickets. Hey, let's feed the crickets. Maybe they'll make some noise. Crickets love fish food. Look at them go. All right, let's get a light and shine it in here so we can check her out and see what she's doing. There she is. She's really hunkered down today. It's cold. It is very cold today. So she's probably just trying to stay warm. So I'm gonna leave her alone. See, here they go. They are happy to be eating. And Flaxseed is sleeping. I'll leave her alone. Anyway, that's what she's up to today. As you can see, Flaxseed's not the only one sleeping. You can see right there. Reese is sleeping. He's conked out. But that's okay. If he's conked out, he's not barking or creating chaos. So sleeping is good. Okay. I can talk a little bit louder now that my daughter is awake and off to work. So let's get back to our program here. And if you're not familiar with copy and deep copy, I would highly recommend watching a couple videos on what it's all about and how to use it and the difference between copy and deep copy, or I should say shallow copy and deep copy. For this function, I'm going to be using the deep copy, which I think the majority of people use. So you have to import copy, and random is already there. We have our hat class. I did very similarly on the function here. I wrote the directions in there just like we did for the practice file. So, and I have to stop saying so many times, just like I need an electrical shocker device that shocks me every time I say it. Okay, so our experiment, I just said it again. Our experiment function has hat, expected balls, number of balls drawn, number of experiments. We create our success count like we did in our practice. I'm going to make it the same. Success underscore M per the directions. M is the number of successes. We need to set this for 0. Here is where we iterate through the range of the number of experiments for X and range number of experiments. I already wrote that out. We need to create a deep copy. We're going to make it our hat equals copy dot deep copy and hat. We're going to draw our balls based on the draw method that is in our hat class. So we'll call it ball draw. It's not going to be 1 or 2. It's going to be our hat. Our hat dot draw. And we're not going to use a number. We're going to use the number of balls drawn that is actually going to be in the call line. It's going to be an integer of whatever number of balls we want to draw. So we're just going to plug in a number of balls drawn like there. We need to initialize our second count, which is the color count, also like in our practice. Now, here is where I simply copied and pasted over what we already wrote in the practice file. Let's see. It can't be balls count. It has to be our ball draw. So ball draw. If our ball draw count is greater than our expected balls color, then we add it, and then we compare it to our length of our expected balls dictionary. And then the very last step is we create our probability variable, which is our success M divided by our number of experiments. And then what we do is we return our probability, like so. In our function, we have created the hat object, which our hat contains 4 blue balls, 2 red balls, and 6 green balls. And then when we print this out, it's already written out. We're going to draw 4 balls, and I put the number of experiments as 10 so that you can see it run. When it's 2,000, it's hard to see, so oops, let's just go ahead and run it. And it's 0.1, which means 10%. That means we got at least 1 right sequence. If you run it very low with only like a very small amount, you might get 0. 0.3, that means 2 of them, 0. Let's see how we can print this out. If we print, I believe, our ball draw. Let's run that. Now, we know what's in our hat. So there's going to be 10 experiments ran right here. You can see every single one. So if it's 0.4, that's actually pretty high for two blue and 1 red. So if you go through this list, you're going to see 2 blue, 1 red. I see 1 right away. It's obviously the more successes you have, the higher the probability is going to go up. But okay, I don't want to print this out 2,000 times. So we're going to take our ball draw out and plug in 2,000, just like the directions state. Let's run it again. Then it says in the directions that it goes up, or maybe it says it goes down. I don't remember, but 20% of the time we had success in 2,000 experiments. Hopefully in this tutorial, you can see how the probability calculator is drawn up. If you had problems with it, or challenges. I'd love to hear from you. If you don't read my blog, I highly encourage you to do so. In my blog, I did go over one part of this challenge that had me going down. Well, it didn't. It was my fault. I thought that you had to calculate something different, and it sent me down this whole rabbit trail that took a few hours, and turns out I didn't even need to be doing it that way, so that ate up my time. But so anyway, go over to my blog if you want, and you can read about how that messed me up. But once I realized that that's not what the function or what the challenge was calling for, it went a whole lot smoother. So I said it again. I don't know what it is. I need to change my vocabulary. Now I'm rambling. I am going to let you all go, and thank you so much for watching. And if you're still here all the way at the end, cookies to you. If you have any requests for what we should go over in my next video, I'd love to hear it. We could do the, I think how many of it, this is the third one. There's 2 more in the Scientific Computing with Python course. We could go over those 2 next, or if you want to do something else, that's fine too. I'd love to hear from you. If you like seeing all things flaxen related, that's great. Anyway, I'm signing off. Thanks for joining me, and I'll see you next time. Take it easy.